Okay, another 3x3 system. We left off the last video with a 3x3 system. Here we go again. Now again, you've got to make a plan. And unlike the last example, where the middle equation, I believe, was only with two variables, all three equations have all three variables. So as I mentioned, you need to make a plan to try to eliminate one of the variables by taking two equations, eliminating the variable, and taking two equations, eliminating the variable. So I'm looking at all positives, all negatives, all positives. No real advantage there sign-wise, but I do like this guy Z, and then I like this guy Z and this guy 3Z. I think I can knock out the Z's first. So I'll take the top two equations here first, and I'm going to try to knock out the variable Z. So I'll leave the top equation alone. Hope I left enough space here. These are a little longer problems, and then I will multiply through by -1, and I will end up with, x plus y equals 5. Only x and y. I like that. Now I'm going to either take the top equation and the bottom one, or the middle equation and the bottom one, and knock out the z's. I think I'll stick with the top equation, but to get the z's to cancel out, I'm going to make this guy a -3z. So I've got to multiply through by -3. So -3 all the way through both sides, every term on the top is -9x plus 6y minus 3z is equal to -3. Leave this guy here the same. 4x minus y plus 3z is equal to -2. So you can see the z's are going to cancel when I add straight down, but I end up with -5x, and it looks like plus 5y equals -5. Now I kind of like this, because if I was to divide through here by -5, every term by -5, I would get x minus y equals 1. And look at this guy and look at this guy. You couldn't ask for two simpler looking equations in a 2x2 system. So I'll stack him underneath here. X plus y equals 5. I get 2x is equal to 6. I get x is equal to 3. So my answer is 3 comma something. I'm going to have an ordered triple here. Now I start looking through my answers. Answer A has a 3 in the x spot. Answer C has a 3. I've already eliminated two of them. So I got her down to a 50-50 if nothing else. But once I know x, I'm going to go back to here. You could go back to here. You could go back to this one if you wanted to. I'm going to go back to here, and I'm going to plug 3 in for x. I get 3 plus y equals 5. Subtract 3, I get y is 2. Now I look at my answers here. Oh, I know it's got to be answer C, because only answer C has a 3 in the x spot and a 2 in the y spot. And then I can go back and find z, but for both of them it looks like it's -4. I'm not so interested in that now, but I could take any one of these equations, plug 3 in for x, plug 2 in for y. 3 times 3 minus 2 times 2 plus z is equal to 1. That's 9. That's 5 plus z is equal to 1. Z is equal to -4 if I subtract 5 from both sides. Now, I've done a few of these in my life, and you haven't probably done quite as many. So there's a lot of steps, and it's easy to mess up, and you start getting answers that don't look like they can match anything. Remember, work backward. If it's a multiple choice test, plug each one of the answers one at a time in for x, y, and z. It's going to have to satisfy all three. Now that's a lot of algebra. You got to be careful with all those signs, and you can make a silly mistake. It's not foolproof, but at least it gives you a plan B if you need it. Okay? Now, this next guy, we're starting to combine, actually, I put 34 here. This next guy up here says, which of the following is equivalent to the expression below? Well, you're adding two polynomials, two trinomials as a matter of fact. The best thing about that is when you're adding, you don't have to worry about signs changing. In fact, you can just drop parentheses here. I get 7a squared plus 5a plus 3 plus, now I am going to put -3a squared in the parentheses so you don't get the negative and the plus sign somehow messed up. And then plus 2a and a -4. All you have to do is combine like terms. This is 4a squared. This is plus 7a. You have a plus 5 and a plus 2 plus 7a. And then this part here Add the constants, a plus 3 and a minus 4 is a minus 1. And so I get 4a squared plus 7a minus 1. Hopefully that matches an answer. It looks a lot like answer A. Now those answers for problem number 33, they're very similar looking with some differences in signs and such. They usually put a logical answer, an answer that looks logical because it's a consistent type of an error, a common type of an error that students sometimes make. Probably something here with the signs in the first couple of terms. Be careful, okay? Be very careful. And if you think you need to be careful for addition, you need to be careful for subtraction. Because that subtraction means you're subtracting all of this. Now I talked about this on a problem that we were solving a system of equations by substitution. I'm going to drop the first set of parentheses. M minus n, the expression quantity m minus n minus quantity n minus m is equivalent to. I'm dropping the first set of parentheses, but this is like a negative 1 that I'm going to multiply through by. That'll be minus n plus m. So when I combine like terms, I have 2m minus 2n, and hopefully that matches one of the answers. And that one looks a little bit like answer A. There we go. Be very careful because of that subtraction sign. Slide in a 1 right next to it so that you remember to distribute. And I'm going to do the same thing here with problem 35. See the subtraction sign right here? I am going to put a 1 right in there that I'm going to distribute by. So the first set of parentheses doesn't have anything in front of it like down here. Just drop those. But this is like a minus 1 or a negative 1 that I'm going to distribute over this trinomial here. That's going to give me minus 2x squared plus 4x, negative times negative, minus 7. Now I start looking for some like terms. I like to underline my like terms with the same number of little underlines, and then I like to cross them off as I go. So I have 3x squared and a minus 2x squared, that's x squared, cross it off. Now, here again, it's multiple choice. Check your answers. Well, they all have an x squared. No help there. Then combine your x's, a plus 2 and a plus 4x is a plus 6x. Does that eliminate any answers? Yeah, the bottom two. It eliminates the bottom two, B and D. So it's got to be A or C, so now we got to combine a minus 8 and a minus 7. Careful with those signs. Negative 8, negative 7, negative 15, minus 15. This is answer A. That's 3 A's in a row, I think, here. I don't know if I even marked the answer for 32. 32 was... looks like answer C for 32. Alright, sorry about that. I forgot to write that one down. Okay, now we get into some factoring and some division and things. When factored completely. Now, you guys have been factoring trinomials since Algebra 1. Notice here, you have 4 terms. If I have to factor some of the 4 terms, I'm going to keep my fingers crossed and hope that I can factor it using grouping. And that's my goal here, is to see if I can do this by factoring with grouping. And I usually, not always, but I usually just start off with the first 2 and the last 2 grouped together. The first 2 have a GCF of x squared. That would leave x plus 3. The last 2 have a GCF of 4. But notice here, plus plus, positive plus, minus minus. I don't want to factor out just a 4. I want to factor out a negative 4. And that would leave an x. When you factor negative 4 out of negative 4x, it's like dividing. Negative by negative is positive. And then I factor out the negative 4. I divide negative 12 by negative 4. That's a positive 3. Which is good. Because if I don't match those binomials, this isn't going to work. So I would have to try maybe a different grouping. Maybe the first and third, the second and fourth. I think it'll work that way as well. But I got this one going. Now I factor out the GCF, which is x plus 3. It's in both. That leaves x squared minus 4. And I'm done. Except that I kind of noticed that it said factoring completely. So maybe I better check. Does that factor? No. Yes, this one does. That's a difference of squares. So this factors to x plus 3, and then difference of squares in x and an x. A 2 and a 2, one's a minus, one's a plus. And let's see if I can match an answer here. Based on what I have written down, that looks a little bit like answer B, even though it's written in a slightly different order. I mean, you can throw out a C and D right away. All right, answer B there. Well, at least the string of A's have stopped here. Hopefully not for your grade. All right, next one up. Find the quotient. Now, the problem is already set up this way for long division. And I am going to have to do long division here, but you can get away with synthetic division here. So I'm going to do it both ways because you always need to see that long division. What times x gives me x to the third? Well, that would be x to the second. So I like to line up my like terms vertically with my quotient and my dividend. X squared times x is x to the third. X squared times minus 4 is minus 4x squared. Now this is where I like to subtract, but you sometimes can make silly mistakes with subtraction if you're not really careful with your signs. So what I do is I add the opposite. I'm going to change this to adding the opposite by taking the opposite in there and adding straight down. Well, the x cubes cancel, and that gives me 6x squared, and I bring down the next term to start the process all over. What times x gives me 6x squared? That would be a plus positive 6x. 6x times x is 6x squared. 6x times minus 4 is minus 24x. And here again is where I would subtract. But as I've said before, I usually like to add the opposite. So opposite, and then add. These cancel. It looks like I'm going to get a positive 8x. No, just 8x, not an 8x squared, just a positive 8x. Bring down the next term, it's a minus 32, start it all over again. What times x gives me 8x? That would be a positive 8. So plus, because of the positive. Negative, it's going to be a minus. 8 times x is 8x. 8 times minus 4 is minus 32. And you can see what's going to happen next, because if I change the signs and add, I get a remainder of 0. So this is my answer right here. Now remember I said you could use synthetic division here. Look at your coefficients of your dividend. They're 1, 2, negative 16, and negative 32. And you're dividing by x minus 4, so the 4 goes here. Because it's always in the form x minus your constant. If this was x plus 4, this would be a negative 4. So bring the first number down, then you multiply, then you add. Then you multiply, then you add. Then you multiply, and then you add. And there's my remainder, which I usually circle or underline. So this is going to be my depressed polynomial. Why is it depressed? Because it's married. And I have, this is my constant term, this is my x term, this is my x squared term. I have 1x squared plus 6x plus 8. There it is. Same answer. Now I'd like to do synthetic division down here, but I want to divide it by a divisor that's in the form x minus a, and this is 3x minus 7. Now you can kind of sidestep that by dividing this and dividing this by 3. You're going to get a lot of fractions. Got to be careful. So I'm going to go through long division. And this is for you, Mr. Dietrich, who didn't teach us synthetic division in high school when you should have. It would have saved us a ton of time. But I got good at long division all the same. What times 3x gives me 3x to the third? That would be x to the second. 1x to the second. Then I multiply. Then I subtract, or as I mentioned before, add the opposite. So this becomes a negative, this becomes a positive. I add straight down. Whoa, everything cancels here. So I don't just bring down the next term, I bring down the next two terms. All right, what times, I don't really need that 0 there, I was just trying to emphasize that. What times 3x gives me 15x? That would be a positive 5. 5 times 3x is 15x. 5 times minus 7 is minus 35. You can see it again. You're not going to have a remainder of anything other than 0 when I add down. Now, if there was a remainder, let's say the remainder had been 10, then you would have to write the remainder as a rational expression. If it's a positive 10, you would write plus 10 all over your divisor. If it's a negative 10, you would write minus 10 all over that and attach it to your quotient here. But in this case, my remainder is 0, so this is my answer. Hopefully that matches one of them. It looks like it matches answer D. So I'll mark that one there as answer D. Okay. Along with being able to factor by grouping and being able to factor trinomials using like the reverse FOIL method or the bottoms up method, I think some of you guys use the diamond method. What I would suggest here is memorizing how to factor the sum and difference of cubes. Now again, there's a way to check your work. you could take each one of your answers and multiply. That'd be 6 multiplications, combine like terms and see which one matches the original problem. But I'm going to just say it's a lot easier if you just memorize the factoring. And that is that if you have here, because it's a sum of 2 cubes, if you remember that x cubed plus y cubed is equal to x plus y times the quantity x squared minus xy plus y squared. Notice that it looks exactly the same as this, except that, what's being squared, same sign. First term squared, opposite sign, take the product, always, always, always a plus, last term squared. Because if you have a difference of cubes, it looks like an x and a minus and a y. First term squared, opposite sign. The product, always, always, always a plus, and the last one squared. Now this guy up here, 8a to the third, is 2a times 2a times 2a. That's a perfect cube. So when I go to factor this one down, it's going to be this guy here. I'm going to put a 2a and I'm going to put a c with a plus sign. It's the first term squared. That's 4a squared. Opposite sign. Take the product, 2ac, always, always, always a plus, and then the last one squared. And hopefully that matches an answer. And it looks like it's going to match answer D. Now some students will think, oh wait a minute, you got a trinomial, maybe this factors further. No. Now I don't remember the last time I saw a sum or difference of cubes where the trinomial factored somehow factored again. You're safe. This guy down here, 42, I think this is the first problem on the last page, if I'm not mistaken, of your review. Which is the polynomial of the given graph? Now, I don't have the polynomial written down. I don't have to have the polynomial written down. I can figure it out based on these 3 points. The x-intercepts. Remember how I mentioned in a previous video how the x-intercepts and the zeros of a function and the roots of the associated equation are all related to one another? Well, I'm writing the function, so I need the values that are going to give me those zeros. So it's always in the form x minus whatever the root is. I have a -1, I have a +1, and I have a +2. So you're looking at this and you're thinking, well, okay, I'm going to have an x minus -1, an x minus 1, and an x minus 2. An x minus -1, an x minus 1, and an x minus 2, and I'm done. But I don't even know if they put that down as a choice. Hopefully they did not. I think they did. So you think, oh, I matched my answer. It looks like it's going to be answer D. Well, one more thing to keep track of. Notice how at these x-intercepts your graph crossed, but not here. It just touched the x-axis, didn't cross the x-axis. So this means that you have multiplicity 2. These are multiplicity 1, but the 1 gives me multiplicity 2 here, which means the x minus 1, there are 2 factors of it. Now when I go to look at it, it looks a lot like answer A. That's a little tricky. These are called cross points. This one's sometimes called a touch point. That means even multiplicity. And based on the way the graph is and the way that it looks like it's going to be 2, I don't think he'd try to fake you out with anything of higher degree than that. So be very careful on this. Alright, well, it looks like we've got maybe one more video to go, and then we will be through all 50 problems.